Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 9 of lesson number 1, atoms and molecules. So as you all aware of that this is the last part for the lesson, right? And so sorry, and we will be discussing here more about the mole concept. We will be discussing about the relationship between the molar mass, then relationship between after molar mass we have mole and the Avogadro's number. Now if you all remember in the last part itself, we discussed about the like molar mass in detail, how to calculate that and all, and how to and what is the difference between all of them, right? Atomic mass unit, then we also studied one more unit over there, right? So I hope every one of you are clear with whatever we have discussed till part 8. Now we will be moving further and we will be studying more about mole with different examples, the relationship that exists between all of them, right? So now I just want each one of you to please go through whatever we have discussed so far in the lesson, because this is going to be the last part for the lesson where we will be even discussing on the 11 different exercise questions as well, right? So I just want each one of you to please go through it all. So we started this lesson by discussing about the philosophers, that is Maharishi Kannad, Pakuda Katyayama, then we have Democritus and Leucippus. Whatever their inputs were on this like atoms, we just discussed on all of them in detail in short, like, right? And what exactly was the conclusion after that, like, because Maharishi Kannad, Democritus, Leucippus, Pakuda Katyayama, they all were behind finding out what exactly an atom is. So they said that if we take any matter and if we go on dividing it further, we will reach a point where we will come across the smallest particle that exists, right? And he named those smallest particle as Parmanu. So Maharishi Kannad, named that atom as Parmanu. So whatever we know it now as atom was named as Parmanu before by Maharishi Kannad, right? So I just want you all to please go through it, and I hope now when I tell you to write a note on all these things, like on any of the topic from the lesson which we have studied so far, you will be able to write a brief note on it on your own, because we are revising it as well, right? I hope everyone is going through this slide. Then we discussed about Democritus, like what exactly he came across. So Democritus called this indivisible particle as like atoms, and you know the meaning of the word atom itself, indivisible, right? So that is why it was named as you can say atom. Okay, and Antony Lavoisier, he has laid the foundation of chemical sciences by establishing two important laws of chemical combination. How many important laws of chemical combination do we have? We have two important law. Now the first law that we have is law of conservation of mass, and the second law that we have is law of constant proportion, right? So I just want each one of you to please go through it once. Then we discussed on the first law of chemical combination, that is like law of conservation of mass, which states that mass can neither be created nor be destroyed in a chemical reaction, right? That is what we have discussed in the lesson. So I just want you all to please go through this law of conservation of mass. And there's one activity as well which we have studied, which actually you can say that activity supports this law of conservation of mass. So I just want you all to please go through this activity properly, because you need to explain it in your own words as well. Okay, so make sure you all are knowing it. I hope everyone is going through this activity. After this, now we have the second law to discuss, that is law of constant proportion, right? So I just want each one of you to please go through this law, that is law of constant proportion in short. After this, we discussed about John Dalton, like who exactly he was and where he was born, everything in detail about him, right? So I just want each one of you to please go through it as well. Then after that we discussed on the postulates of the Dalton's atomic theory. So altogether we have 6 different postulates of Dalton atomic theory which has been given. I want each one of you to please go through this Dalton's atomic theory, as I am like telling you in every part that Dalton's atomic theory is most important question which can be asked. So I want you all to be prepared with it as well. Okay. After this we discussed on what is atom. So I just want each one of you to please go through like the slide. After this we discussed on like what exactly how big are atoms, right? So I just want you all to please go through this atomic radius part. After this we discussed on like what are the modern day symbols of atoms of different elements. So I just want you all to please go through it once. So these are the explanation that we had discussed, right? Then we discussed on some of the symbols for some elements. This table is very important as like this is going to help you for the right, because for writing the chemical formula you just read it while we were studying about the rules for writing the chemical formula. This is very important that you know the symbols of the elements. Okay, so I just want you all to please go through it. I hope everyone is going through all the symbol. After this we discussed on atomic mass in detail, so I just want each one of you to please go through it. After this, like we your studied about the abbreviation that we use, that is like earlier we used to use it as AMU, that is atomic mass unit, but now according to the latest IUPAC recommendation we don't use AMU. We instead of writing AMU we just write U, that is unified mass, and this unified mass is equal to 1.33 unified mass, right? So I just want you all to please go through this slide as this is also very important. After this, like we elaborated it more by like adding on an example with respect to watermelon. So I just want you to please go through it. After this, we discussed on the atomic masses of few elements. I just want each one of you to please go through it once. After this, we discussed on like how exactly atoms exist. So I just want each one of you to please go through it once. After this, we discussed on like what exactly molecules are. So I just want each one of you to please go through this slide. Even we have like different examples of molecules given here, like oxygen, methane, caffeine, deoxyribonucleic acid, DNA. That these are all examples of molecules, right? So I just want each one of you to please go through it once. After this, we discussed on molecules of elements. So I just want each one of you to please go through it once. After this, we discussed on atomicity in detail. So I just want each one of you to please go through this atomicity part. After this, we discussed on molecules of compounds. So I just want each one of you to please go through it once. What are molecules of compounds exactly? After this, we discussed on this activity which was like supporting the atomic mass. So I just want each one of you to please go through it once. Then we discussed on what exactly is an ion. So I just want each one of you to please go through like what exactly an ion is and know always that ion means it has some charged species. Okay, and this charge can be either positive or negative. And if the ions are positively charged, it means it is an cation, and if it is negatively charged, it is an anion, right? So we have the example of sodium chloride which has been given over here. Always remember the sodium is positively charged because it shares it loses its electron. Okay, and chlorine is negatively charged. Why? Because it takes electron. Okay, it gains electrons. That is the reason. Okay, I just want you all to please go through this slide once. After this, we discussed on the ionic compounds along with the constituting elements. So I just want you all to please go through it once. After this, we discussed on writing the chemical formulas and detail the rules, how to write it and everything. So I just want each one of you to please go through it once. After this, we studied the valencies of some of the ions which have been given in the table. So we have the valency of the ions of the non-metallic elements and the polyatomic ions which have been given along with the symbol, right? And on the top, if you can see, there is a positive and a negative charge. Somewhere you can even see the numericals written, right? So it means they are all the charges or the valencies that they have. That is how like we represent the valencies of the ions, okay? So I just want each one of you to please go through this as well once. After this, we will be discussing on the rules for writing the chemical formula, and I just want each one of you to please go through it once. After this, we discussed on like how exactly to write the formula of simple compounds. So I just want you all to please go through it once. I hope you all are going through the examples which have been given because they are very important. You should be actually knowing the examples, okay? I hope everyone is going through the examples. After this, we discussed on the molecular mass and mole concept, and I hope everyone is going through it. I hope everyone is going through this slide. After this, we discussed on formula mass unit, right? I hope you all have understood this concept of formula mass unit and how to calculate it. It is exactly the same. We did it for the earlier one, how to calculate the molecular mass. It's just that the unit will change. Okay? Then after that we even discussed on mole concept, right? And this was the last concept I guess we discussed. Now we are just left with relationship that we need to study between the molar mass, Avogadro number and the mole, right? So please go through this everyone. I hope everyone is going through this mole concept. After this we discussed more about mole. So I just want you all to please go through it. And this is what I was talking about, that we discussed on like from U to G, that is like from atomic mass unit, how we are using it, the gram atomic mass, right? So I just want you all to please go through it once. After this we discussed about like what exactly one mole is, and this one mole is equal to 6.022 into 10 raised to 23, which is also known as Avogadro's number, right? So I just want you all to please go through this slide as well once. Then we discussed on like who exactly discovered the concept of mole. So I want you all to please go through it once as well. After this we discussed, now we need to discuss about the relationship that exists between mole, Avogadro number and the mass. Okay, now see, 1 mole of carbon, we know it's equal to 12 grams of carbon atom, right? 1 mole, like 1 dozen, is equal to 12, you can say, units, right? That is how 1 mole of carbon atom is equal to 12 gram of carbon unit and is equal to 6.022 into 10 raised to 23 atoms of carbon. Getting it? And when it comes to 1 mole of hydrogen atom, now 1 mole of hydrogen atom is equal to 1 gram of hydrogen atom and it is equal to 6.022 into 10 raised to 23 atoms of hydrogen. And when it comes to any, like any particle, 1 mole of any particle, be it an atom, molecule or ion, is equal to the relative mass of those particles in gram. If you can see, like carbon, it is 12 gram, hydrogen, it's 1 gram, right? So be it any particle over here, it is going to be equal to relative mass of the particles in gram. Okay, and that is equal to 6.022 into 10 raised to 23 number of that particle. And when it comes to 1 mole of molecule, that is equal to molecular mass in grams and is equal to 6.022 into 10 raised to 23 number of molecules, right? So I just want each one of you to please go through it once, or even if you want, you can write this in your book and keep. I hope everyone understood the difference between, like, in one part we the mole part has been given, right? In the center we have the Avogadro number and the mass which has been given. So that is how we have compared it all, right? After this, now we have certain examples given. We have total 3 different examples. See, calculate the number of moles for the following, where we have like 52 grams of helium. Okay, finding the mole from mass, and then we have 12.044 into 10 raised to 23 number of helium atoms. So you need to find the mole from number of particles. Now let's see the solution that has been given over here. Number of moles, we represent that as small n. Okay, given mass, we will represent it as small m. Then molar mass, we will represent it by capital M. Given number of particles, it will be represented using capital N. And then Avogadro number, we will represent it by Na. Okay, after that we have to find out the atomic mass of helium. We have to find out the number of moles, right? So atomic mass of helium is given as 4U, and then you can say the molar mass of helium is given as 4 gram. And now we have the number of moles which is given by given mass upon molar mass. Okay, so given mass becomes 52 and the molar mass of helium is 4. So it becomes 52 divided by 4 and it is equal to 13. So this is how you will calculate the number of moles. Then secondly, we have to find out the mole from number of particles. So we know that 1 mole is equal to 6.022 into 10 raised to 23, right? So the number of moles will become equal to given number of particles divided by Avogadro number. What it will become equal to given number of particles divided by Avogadro number, so n upon Na. So that becomes equal to 12.044 into 10 raised to 23 upon 6.022. Getting it? Because the number has already been given, how much number of helium atoms are present, right? So it becomes n upon Na, and that is how we get the value as 2. Getting it, everyone? So this is how you will calculate it. Now you can change the value for instead of writing 52, take the value as 62 and calculate and tell me what will be the answer. After this, we have the second example as calculate the mass of following. First is 0.5 mole of N2 gas. So we need to find out the mass from the mole of molecule. Then 0.5 mole of nitrogen atom, and you have to calculate mass from mole. Then 3.011 into 10 raised to 23 number of nitrogen atom. So we have to calculate mass from number. And lastly, we have 6.022 into 10 raised to 23 number of N2. So here we need to calculate mass from number again. So see the first one, mass is equal to molar mass into number of moles. Now we know molar mass is 28, right? And the number of mole is 0.5. So you should be knowing the molar mass of nitrogen now into gas. Okay, so it's 28, and when you multiply that with the number of moles, it's 0.5. So it becomes equal to 14 grams. Okay. Then secondly, again have to find the mass, so it becomes equal to molar mass into number of moles. Now here only, because we have only one nitrogen atom, the first one we had N2, so 14 into 14 become 14 plus 14 becomes 28. That is why the molar mass in first one was 28, but here only we have one nitrogen atom, so here the molar mass will be 14 and number of moles will be it's 0.5. So when you multiply that, you get the answer as 7 gram. Okay. Then third we have 3.011 into 10 raised to 23 number of nitrogen atom. So we will give the formula over here. We will use the formula as given number of particles, that is n, divided by Avogadro's number. Now we know Avogadro's number is a constant, that is 6.022 into 10 raised to 23. So when we divide that, we get the answer as 7 grams when you calculate it further. Okay. And lastly, we need to calculate the mass from number, right? So we will use the formula over here is n is equal to n upon Na, and when you further do the calculation, you get the answer as 28 grams. So now, because I'm just stating it and I'm telling you, it won't be easier for you to understand, right? So for that, I want each one of you to do it on your own. Try to solve it by doing the calculations and all. You have the calculation, direct calculation which has been given, but when you do it in your notebook, you will understand it properly. Okay. Now this third example is also again the same, where we are calculating 46 grams of sodium atoms number from mass. So we will again use the same formula, that is given mass upon molar mass into Avogadro's number. Okay, for both the things we are going to do the same. Okay, so now we have the summary discussion to discuss in detail. So see, during a chemical reaction, the sum of the masses of reactant and product remain unchanged, and this is the law of conservation of mass, right? Then we studied about in a pure chemical compound, elements are always present in definite proportion by mass. And this law, we know it as law of constant proportion or law of definite proportion, right? So these are the two laws that we have discussed. Then we discussed about atoms. So we discussed that an atom is the smallest particle of element that cannot usually exist independently and retain all its chemical properties. So we discussed about the two laws. Then we discussed in detail about what is an atom and the properties of it. Then we discussed on molecules. So see, molecule is the smallest particle of an element or a compound which is capable of independent existence under ordinary condition. And we know that molecules, they show all the properties of substance, right? So after discussing about atoms and molecules, further we discussed on chemical formula, and we know that the chemical formula of a compound is going to have its constituent elements and the number of atom of each combining element. Okay. Then we discussed on what are monoatomic, diatomic and polyatomic ions. So if there are cluster of ions, then we call that group of ion as polyatomic ion, and they are going to carry a fixed charge on them. Okay. Then we even discussed on that the chemical formula of a molecular compound. How can we determine that? We can determine it easily by calculating the valency of it, right? And when it comes to any ionic compound, the charge on the ion, we know that charge can be either positive or negative. Based on that, we call it as cation and anion, right? So on the basis of that, we assign it a proper charge on the basis of the valencies. And then we discussed about the carbon 12 isotopes which have been assigned a relative atomic mass of 12, and the relative masses of all other atoms, we can obtain them by comparing it with mass of carbon 12 atom. Okay, and then in the last we even discussed on the Avogadro's constant, that is 6.022 into 10 raised to 23. Now it is not 10 it's written wrong. Okay, so don't get confused. Wherever you see it's 1023, this is wrongly written. It's 10 raised to 23. Getting it? This is how you need to write it. 6.022 into 10 raised to 23. So Avogadro's constant is defined as number of atoms in exactly 12 grams of carbon 12. Got it? And the mole, what is mole now? Mole is the amount of substance that contains 6.022. Again, the 1023 is wrong. It's 10 raised to 23. Okay, what exactly it is? It is equal to 10 raised to 23 specified elementary entities. Okay, and mass of 1 mole of substance is called its molar mass. What exactly it is called as? Mass of 1 mole of substance is called its molar mass. Okay, so I hope you are clear with all the things that we have studied so far in the lesson atoms and molecules. We have even completed with the summary discussion now, right? And I hope you are clear with each and every concept that we studied so far in the lesson. But now we have like 11 exercise questions to discuss in detail for the lesson. So let's see what exactly it is. See, a 0.24 gram sample of compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and 0.144 gram of oxygen. So what you need to do is you need to calculate the percentage composition of the compound by weight. So how will you do that? Reactant on one side, product on one side, right? So how exactly it goes on? See, what you will write, first of all, you have to write given part, that mass of the sample compound is given to be 0.24 gram, mass of boron is equal to 0.096 gram, mass of oxygen is equal to 0.144 gram, right? And now we have to calculate the percentage composition of compound. So it will be like percentage of boron is equal to mass of boron divided by mass of compound into 100. What is the formula I said? Percentage of boron is equal to mass of boron divided by mass of compound into 100. And when you do that, you get the value as 0.096 divided by 0.24 into 100, that is equal to 40%. Okay, but now we have to calculate the percentage of oxygen. So what we will do, 100 minus percentage of oxygen, so percentage of boron, so it becomes equal to 100 minus 40, and we get the value as 60%. Getting it? So that is how you will calculate. Then the second question that we have is, when 3.0 gram of carbon is burned in 8 gram of oxygen, 11 gram of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 gram of carbon is burned in 50 gram of oxygen? And which law of chemical combination will govern your answer? So you have to find out how you have to find out the mass of carbon dioxide which will be formed when 3 grams of carbon will be burned in 50 grams of oxygen. So what you will do, the reaction will be C, carbon when reacts with oxygen gives carbon dioxide. That will be the reaction. So as per the condition, how many grams of carbon? 3 grams of carbon is burned in 8 grams of oxygen. So 3 plus 8 becomes equal to, so total how many grams of carbon dioxide has been produced? 11 grams, right? that is already been given. So total mass of reactant will be equal to mass of carbon plus mass of oxygen, and that is how we get the answer as 11 gram. And when you calculate the total mass of reactant, the total mass of reactant is equal to total mass of product, right? And therefore we can say that you can say it is following the law of conservation of mass, and we can prove it over here. And it also further proves the law of constant proportion as well, because when 3 gram of oxygen, like 3 grams of oxygen must combine with 8 grams of oxygen only, and then only we will get the ratio as 11 gram, right? So it is following both the law of chemical combination, that is law of like conservation of mass, and law of constant proportion. Okay, then what are polyatomic ion? Give examples. So we know that polyatomic ions are the ions that contain more than one atom, but they behave as a single unit. What do they contain? Polyatomic ions are the ions that contain more than one atom, but they behave as a single unit. And the example of this polyatomic ion, it includes CO3 2 minus, H2PO4 minus. These are some of the examples of polyatomic ions that we have. Okay, this you can write in your own words. Then you need to write the chemical formula for magnesium chloride. We know magnesium chloride is MgCl2, right? Calcium oxide is CaO, C A small, O capital. Then calcium nitrate will be, how will you write calcium nitrate? I'll write it over here. Copper nitrate. CuNO3 twice. Got it? Then aluminium chloride will be Al for aluminium, and chloride will be AlCl3. Okay, then calcium carbonate will be CaCO3. Got it? So this is how you write the chemical formula. Now give the names of the element quicklime. So quicklime is calcium and oxygen, CaO. Okay, then the second one is hydrogen bromide. Hydrogen bromide is hydrogen and bromine, HBr, right? Baking powder is it has sodium, carbon, hydrogen, oxygen, so it becomes NaHCO3. What is baking powder? Na, sodium, hydrogen, carbon, oxygen. Got it? Then potassium sulfate is going to have sulfur, oxygen, and potassium. So potassium sulfate is K2SO4. Got it? Now after that, the next question that we have is you need to calculate the molar mass of ethine. Ethine is C2H2. So what you have to do, ethine has carbon and mass of hydrogen. And how many mass of carbon? So 2 into mass of carbon plus 2 into mass of hydrogen. Now why we are taking 2? Because there are 2 carbon and 2 hydrogen which are present. And we know mass of carbon is 12. So it becomes 2 into 12. And the mass of hydrogen is 1. So it becomes 2 into 1. So now what do you think what it will be equal to? 24 plus 2, right? So it becomes equal to 26 grams. This is how you will calculate for sulfur as well. Now sulfur molecule has, like, for the second one, it's very easy for calculating it for sulfur. It's like there are 8 sulfur molecule. So 8 into the mass of sulfur, and mass of sulfur is equal to 32. So it becomes equal to 8 into 32. 8 into 32 is equal to 256 grams. Got it? Then for phosphorus molecule P4, now there are 4 atoms, right? So 4 into phosphorus ka mass is 31. So it becomes equal to 124 grams. Okay. Then for fourth one, hydrochloric acid, we have mass of hydrogen plus mass of chlorine. Now mass of hydrogen is 1, that of chlorine is 35.5, so it becomes equal to 36.5 grams. Got it? Then for nitric acid, we have mass of hydrogen, mass of nitrogen and oxygen, and when you calculate it, hydrogen is 1, oxygen is 14, and you can say nitrogen is 3. Sorry, nitrogen is 3, hydrogen is 1, nitrogen is 3, and oxygen is 14. So when you add that, you get 63 grams. I hope you got it how to calculate it. Now you have to tell me what is the mass of 1 mole of nitrogen atom. See, atomic mass of nitrogen is 14U, right? And mass of 1 mole of nitrogen atom will be equal to atomic mass of nitrogen atom. What it will be equal to? Atomic mass of nitrogen atom. So therefore 1 mole of nitrogen atom is 14 gram. Atomic mass and the mole of nitrogen will be equal. Okay. Then we have atomic mass of aluminium. Now they have given us to calculate it for 4 molecules of aluminium atom. So see, the atomic mass of aluminium is 17U. So mass of 1 mole of aluminium will be 27U. And you have to just calculate 27 by 4 and you get the answer as 108. Got it? Now 10 moles of sodium sulfite. Now you have to calculate it for all. You have to first calculate the molar mass for all. Okay? So you'll write like 2 into mass of sodium, then mass of sulfur, plus 3 into mass of oxygen, and you will get the answer as 126 grams. So 126 into 10 will be equal to 1260 grams. Got it? So first you have to calculate the molar mass and then you have to multiply it by the number of moles which has been given. It's very easy. Okay. Now you have to convert this into mole. 12 grams of oxygen gas. So what you will do over here is 2 mass of oxygen will be equal to, because we write it as O2, right? So 2 into 16 will be equal to 32 grams. And now the number of moles is equal to, like you will use the formula as the one example that we saw. Mass, number of moles is equal to mass given upon molar mass of oxygen. So mass given is 12 and molar mass of oxygen is 32. So 12 by 32 you get the answer as 0.37 moles. Okay. Then for water you will do the same. First you will calculate the molar mass and you will get the molar mass as 18 gram for water. Then for number of moles, we know the formula as number of moles is equal to mass given upon molar mass. So mass given is 20, molar mass we calculated it to be 18. So the answer will be 1.11 moles, right? Then for third one, 22 grams of carbon dioxide. So first you have to find out the molar mass of carbon dioxide and then you have to divide that given mass, that is 22 divided by molar mass of carbon dioxide. So it's 22 divided by 44 and you will get the answer as 0.5 moles. Got it? How to convert this moles? First you have to calculate the molar mass and then you have to calculate the number of molar mass that has been given. Molar mass of carbon dioxide and water and all. It's again very easy. Then what is the mass of 0.2 mole of oxygen atom? So mass of 1 mole of oxygen atom is 16U. So what you will do, 0.2 into 16 and you will get the answer as 3.2 grams. Okay. Then mass of 1 mole of water molecule is 18U, right? And because you have to calculate it for 0.5, so what you will do, 0.5 into 18. So you will get the answer as 9 grams. So it's very easy. You just have to know the mass. Okay. Once you know the mass, you have to just calculate it with the number of moles given. Now calculate the number of molecules of sulfur S8 present in 16 gram of sodium sulfur. So for that, first you will calculate the molar mass of sulfur and when you do that you get the answer as 256 grams. Okay. Now the mass which is given over here is 16 grams. So what you will do, number of moles is equal to given mass upon molar mass of sulfur. Given mass is 16, molar mass is 256. So you get the answer as 0.062. Okay, and now because we have to calculate the number of molecules of sulfur, what you will do, number of molecules is equal to number of moles into Avogadro's number. Number of mole is 0.062 into Avogadro is 0.6.022 into 10 raised to 23, and when you calculate that, multiply that, you get the answer as 3.763 into 10 raised to 22 molecules. Okay, that is how you will calculate it. Now the last question for the lesson, calculate the number of aluminium ions present in 0.051 gram of aluminium oxide. So there is a hint given that the mass of an ion is same as that of the atom of the same element. So atomic mass of aluminium is 27 U. See, now you have to calculate the number of aluminium ions in 0.051 gram of aluminium oxide. We know 1 mole will be equal to 6.022 into 10 raised to 23, right? So when it comes to calculating 1 mole of aluminium oxide, it becomes equal to 2 into mass of aluminium plus 3 into mass of oxygen, because it is Al2 into Al2O3. So 2 into aluminium and 3 into oxygen. And when you calculate that, you get the answer as 102 grams, right? So 1 mole of aluminium oxide is 102 grams, that is equal to 6.022 into 10 raised to 23. So that is how, if you have to calculate it for 0.051, you have to just multiply that with the Avogadro number and done. So you get the answer as 3.011 into 10 raised to 20 molecules of aluminium. Got it? So this is how you will further do the numericals part on your own. Make sure if you have any doubt, you can ping out, like we will reach out to you. Okay, now there's a group activity, play a game for writing the formulae. So you have to make play cards with symbols and valencies of the elements separately, and each student should hold two play cards, one with the symbol in the right hand and the other with the valency in the left hand. Now keeping the symbols in place, students should crisscross their valencies to form the formula of the compound. Okay, these are just few games suggested for you all. Then example 2 is, what you can do is a low cost model for writing the formulae. You can take some empty blister packs of medicines, cut them into groups according to the valency of the element as shown, and you can make formula by mixing one type of ion into other, so like they have done over here. So this is for you only, like you can do it on your own. You will not require my help over here. So here I complete with this lesson, atoms and molecules, and I hope whatever we have discussed so far in the lesson, every one of you are clear with it. Okay, now in the next part I'm even going to start with the next lesson that we have. But before starting with that, I hope every one of you are clear with this lesson very properly. Okay, and if you have any doubts, like you can go back to the video, and even if you're not understanding the same thing, you can come back to us. Okay, so as I said, in the next part I will be starting with the next part, and always remember whatever point I have stated is very important. Like I stated about the Darwin's like postulate, which is very important over here. The mole concept is important, but for some of you it is even been deleted as well, right? So if it is deleted, make sure that you're going through your syllabus and then further doing it. Okay, because there are many numericals with moles concept. If the mole concept is deleted, you don't have to solve the mole concept numerical as well. Okay, so now I'm ending the lesson over here, atoms and molecules, and I will be starting with a new lesson in the next part. Thank you everyone.